All right, we've established some key terminology with relation to polynomial functions, and now it is time to graph. Our first graphic example is going to be this. I'm just throwing everything at you and we'll see how it goes, okay? The very first step when you are sketching a function is you want to determine how it ends. We want to know where it's going so that we know how to finish it off. First and foremost, I need to figure out the degree of this polynomial. I have 2, an invisible 1, and then a 3, which indicates that this is a degree 6. Degree 6 is an even degree, which means that either my polynomial is shaped like this, or it's shaped like this overall. It's going up or it's going down. Okay. However, I have a lead coefficient that's negative, which indicates that it's going to be going down. My end behavior is negative. So I'm going to start at Q3 and I'm going to end at Q4. And what you might find is helpful is drawing a quick Cartesian grid off to the right here. I'm going to label this with my quadrants. And I'm just going to add some arrows. So I'm starting at Q3, which means I'm going to go down here on the left-hand side. And I'm going to end up at Q4 over on the right-hand side. That's how my function is going to end. Now we need to figure out what is happening in the middle. In the middle, we can use the x-intercepts, and we need to determine also what is going to be happening at the x-intercepts. We have 3 different x-intercepts here. Our first x-intercept is x is equal to 1. We also have x is equal to -1, and x is equal to 3. I got those by looking at each of the individual factors of my polynomial function. Once we've determined our x-intercepts, we then are going to take a look at what happens at each one. Our first one, x is equal to 1. This factor has a degree of 2. I can see this because up here, where I have an x minus 1 as my factor, there's the degree of 2 right there. Recall that degree of 2's look like parabolas, so I'm going to bounce back. At this x-intercept, my function is either going to do this, or it's going to do that. Some kind of rebound. Let's take a look at the next one. At x is equal to -1, that comes from the factor x plus 1. X plus 1 has a degree of 1. Recall that degree of 1's just look like straight lines. So it's either going to look like this or like that. And we'll figure out the direction in just a sec. My last factor is x minus 3 cubed, and that's where I got the x-intercept x is equal to 3. X minus 3 has a degree of 3. And so this is going to cross at the x-intercept looking like a cubic function. So either like this or like this. Not totally sure what yet. Now we're going to use all of this information and we're actually going to draw a sketch. The very first thing that I'm going to do is I'm going to add my end behavior onto the graph. I know that it's going to start over here and then go down towards -infinity to the left, and it also goes down towards -infinity to the right. Now, I haven't been provided with any numbers or anything, so I'm going to label the x-axis so that all of my x-intercepts fit on it, and it looks like I can just count by ones, and I'll be fine. I'm now going to plot all of my x-intercepts. I have an x-intercept at 1, an x-intercept at -1, and an x-intercept at 3. And now we're going to deal with these literally going from left to right. My x-intercept of -1, we said was a degree of 1, and it's going to be at a straight line. Well, I'm coming down from the bottom here, so that means that I'm going to draw, literally, a straight line through it. My second x-intercept, going from the left, is at x is equal to 1, and this has a degree of 2. Well, I'm coming at it now from above it, which means that I'm going to rebound and go right back up again. My third x-intercept is at x is equal to 3. This is a degree of 3, and it looks like a cubic function. I know I need to end down here, and so I'm going to cross. I'm just going to do a little curve. I'm going to cross, trying to respect that cubic function. And I'm just going to extend some lines here, indicating that my graph goes off to infinity in the negative direction, both in Q3 and Q4. Not that bad. And for reference, that's the function that you just drew. Pretty sweet. Okay, to recap, we started by determining the end behavior. Q3 and Q4 were this function's end behavior. Then we determined where our x-intercepts were and what happened at each one. Finally, we plotted everything and we basically connected the dots, respecting the rules of what we had said. Let's do 2 more. Okay, let's do our second example here. In this question, you're being asked to not only sketch the polynomial function, but you're also being asked to determine where it's positive and negative, and I'll show you how to do that after we do the quick sketch. First things first, let's determine our end behavior. We have a degree of 3 polynomial, and the leading coefficient is positive. I don't have a number in front of it. It's implied that that's 1. So I'm going to say positive coefficient. And a degree 3 positive coefficient moves from Q3 to Q1. If you don't have that memorized, it's okay. Reference that summary chart that we did in lesson 1.2. What I'm going to do here is I'm going to literally draw on the 2 end behavior arrows just as a reminder. So I'm moving from Q3, I'm starting there, and on the right I'm ending at Q1. And now it's a question of determining what's happening at each of my x-intercepts. So I have 3 x-intercepts. X is equal to 0, x is equal to 3, and x is equal to -4. Again, I got those just by looking at the factored form and setting each of the individual factors to 0. All of these have a degree of 1, which means that they're all crossing in some type of straight line. Okay? Now let's plot. I'm going to add numbers to my x-axis here. And I'm going to plot my 3 intercepts. One is at 0, one is at 3, and one is at -4. Okay, moving from left to right, I'm going to start with the -4. I know it has to start down in quadrant 3, so I'm going to be crossing like this. And then that means I have to cross at 0 going down, because I'll be coming from above. And then I got to cross at 3 going the other way, up like that. And so literally I can just go ahead and connect my dots. I'm going to draw that a little bit smoother. Beautiful. Let's do the second sketch and then we'll talk about the positive negative business. Second sketch, I'm going to follow the exact same process. So first things first, I have a degree 3 polynomial here, and my leading coefficient is negative, which means that I'm going to be moving from Q2 down to Q4. Let's draw those arrows in, starting at Q2, down to Q4. from here, let's determine my x-intercepts. I only have two. One is at 2. One is at -5. My x-intercept at 2 has a degree of 2. And my x-intercept at -5 has a degree of 5. Degree of 2 means that I'm doing that little bounce back business. So it's either going to be like this or this. Oh, and sorry, I don't have a degree of 5. This is a degree of 1, so it's a straight line. I'm going to plot these on my graph, first by adding some numbers. And plotting my x-intercepts. My first x-intercept is at -5 and then 2. So we're going to start from the -5 one because that's first on the left-hand side. That's a degree of 1, which means I'm just going to be crossing down. And then my x-intercept at 2 is a degree of 2, which is a bounce back. So in this case, I'm going to end up coming from down here, and I will need to do a bounce back of sorts. Okay, and I'm just going to connect these. It doesn't have to be pretty. Ooh. The goal here is that you're sketching your x-intercepts as well as your end behavior. You'll notice with all of the examples that I've done today, I have not added a scale to the y-axis. Part of the curriculum for advanced functions is not that you need to know how far up or down these little bumps and grooves go. What matters right now is that you know what the end behavior is, you know how your graph is crossing the x-axis, and you know where your x-intercepts are. Okay? Last thing, we were asked to determine where the polynomial is positive and where the polynomial is negative. Positive literally means when is it above the y-axis. So I'm literally just going to take a highlighter and I'm going to say, when is my polynomial above the y-axis? Well, for my first function, let's make that nice and big. It's above the x-axis here and here. For my second polynomial, it's only positive, it's only above the y-axis over here. When is it negative? Well, when it's below the x-axis. So for my first one, that's on this side, and that's for this little bump. And literally the rest of the time for my second polynomial is when it is negative, all the way down here. So let's go ahead and let's state our intervals. I'm going to say for the first one, my polynomial is positive between -4 and 0. And I'm just using set notation here. As well as, so I write that little u, as well as after 3. One quick thing I'm going to notice here, I used square brackets and that was incorrect. I'm going to change that to curved brackets. Why curved brackets? Curved brackets because 0 is neither a positive nor a negative number. And so at -4, my function is literally equal to 0. So my function is neither positive nor negative. And so it's only when it is approaching -4 that it's there, hence why we are using the curved bracket. My function is negative on the intervals -∞ to 4, again curved bracket, and also between 0 and 3. This little u looks like a parabola. That means union. Union means and. It's a fancy way of saying and in math, so we add those two together. For my second polynomial here, this is a positive polynomial. It is positive literally before -5. So anytime between -∞ and 5, my polynomial is positive. And my polynomial is negative. Sorry, that should be -5. between -5 and positive infinity. Those are the intervals where my polynomial is positive and where my polynomial is negative. Okay, that's it.